So there's a ton of stuff on the screen here this morning. If it's in green, you do not need to write it down, right? So notice this note right here. I'm going to try to do that more during this quarter. But if it is in green, you do not need to write it down. That I'm just, to be honest, I'm trying to cut as much as I can so that you're not trying to like scribble down everything, because I know not all of us have a printer. But sometimes there are just like really important things that I need you to write down. So I know that sometimes it will look like a lot. Today looks like a lot, but I do want to just mention, like, I'm going to go over the things in green, and I might write something next to them, but you do not necessarily need to write it in your notes. Remember, these are your notes, and so like you write down what you think is important and necessary, just like you would if you were in college. Cool. All right. Thank you to the 80% of you who are ready to go. Appreciate you. All right, let's jump in. So today we're going to start a new unit, and I'm super pumped about it. It's one of my favorites. It's about polynomials. So in our math career, I just want to like set the stage. In our math career, you learned first, probably when we started learning about graphs, you started learning about coordinate points. So you started saying, okay, like what is this point? Maybe it's like 3, 2 or something, right? And then you learned that if we put a bunch of points in a straight line, right, then we can create a linear line, a straight line that looks like this, right? Y equals mx plus b, you might be thinking, those types of things. And then at some point during maybe 9th grade, or maybe this year, right, we for sure did it this year, we started thinking about parabolas, right? Parabolas, what happens when you have a quadratic? Remember, we had x squared. So we started with just like x comma y, and then we moved into like just y equals x, or mx plus b. And then we moved into y equals x squared. So we've already been dealing with tons and tons of different lines and points on a graph. Okay. Today, we're going to start to talk about polynomials, and it actually includes y equals x and x squared, right? It actually includes linear and quadratic. So you're already like part of the way towards knowing what a polynomial is. So let's start with just 2 words for vocab. I want you to make sure that you have the word polynomial written down, right? So polynomials are expressions with variables and numbers. That's it. They're expressions with variables and numbers. They're being added and subtracted together. There are some rules around, like you can't be dividing by a variable. You can't have the variable in the exponent, some types of things like that. We're not going to dive deep into those. The big idea is that polynomials are expressions with variables and numbers. So something like 2 plus x, that is a polynomial, right? Something like x squared plus 3x minus 4, that's also a polynomial, right? That's variables and numbers, and they're going to be, that's an expression. Polynomial. All right, poly, just for those of you who like, I assume it's Greek, but I don't know for sure. Poly means many, and nomials means terms. So polynomials literally means many terms, right? Remember, a term is just like a piece of the puzzle, right? So many terms, polynomials means many terms. Pretty cool. Pretty cool, pretty cool. All right, and then the degree, I also need you to have this word written down, the degree. Right? The degree of a polynomial is just the biggest exponent, the largest exponent. Right? The biggest exponent. So if I have x to the 4th plus x to the 6th plus 10x squared, right? My exponents are the small numbers, 4, 6, and 2. What's my biggest exponent here? Somebody put it in the chat. What's my biggest exponent? Out of 4, 6, and 2. 6 for sure, Mira. So my 6 right here, the 6 is my biggest exponent, and it is the degree. So I'd say the degree of this polynomial is 6. Roxana, 10 is a really good guess because it is the biggest number in the, it's the biggest number in our polynomial. However, the degree only works with the exponent, So out of 4, out of 6, and out of 2, the biggest exponent is 6. 10 is what we call a coefficient, right? It's a coefficient, it's not an exponent. No problem, Roxana, you did a great job. I'm sure many other people thought that too. I actually did that on purpose. I was trying to trick you. Yeah, that's why I made 10 such a big number. Yeah, good job. Okay, we're gonna draw, we have our 2 words that we're gonna use today, polynomial, right, and degree. We are going to draw a lot of them. So if you wanna quickly just like make some XYs, and remember, these are sketches. I'm not worried about perfect things. You'll see me sketch and erase a couple of times, right? So we are gonna draw a bunch of graphs, right? We just wanna make sure that we understand the shape. So the goal today for this section is to understand the shape of the graph, okay? The shape. So polynomials are a little bit like us. They have first names and they have last names, right? So they have first names and they have last names. The first names are based on the shape and the last names are based on the terms or the size, right? So first names are based on the shape, last names are based on the size. We've already dealt with a few of these top ones here. So if our degree is 0, right, that means that we just have a number, like the number 18 or something, right? The first name of these functions is constant. And this means something like y equals 2. It looks like this. It's a flat line. This is our constant line. If it's just flat, it's constant. That's our positive constant. Our negative constant is below the graph like this. Below the graph. So if you have only a few things written on your paper, I want to make sure that you have the degree, the word constant, and then the XY and the flat graph. The XY and the flat graph. Okay. If you have nothing else on your paper, make sure you have that. I want to make sure I don't lose anyone. Can you put an R in the chat when you're ready to move? Put an R in the chat. Move. Awesome. Thank you. Cool. I know there's a lot of drawing, so I just don't want to lose anybody here. Thanks to those of you who put R in the chat for the direct message. Sweet. So we have our constants. Constants are flat. Then as we started growing, we learned about y equals x, our linear graphs. And they make, as you guessed, a line, something like this. And we have y equals x. That's our positive graph. It's going up at the end. And then we have our negative version, y equals negative x. What happens with y equals negative x? What happens to the graph? Is it headed up at the end or down at the end? Yeah, for sure, Wendy. Thank you. It goes down at the end. It goes down at the end. Right, so it's still a straight line. It's still a linear line, right? But it's positive one goes up at the end, negative one goes down at the end. Amazing. All right, so we have constants, flat, linear line, right? What is the word that goes with x squared? When we have x squared in our problem, right? When our degree, our largest exponent is x squared, what's the word that we use to describe it? What's the word we use? Starts with a Q. Starts with the Q. Anybody got it? Yes, thank you for those direct messages. Quadratic. Absolutely. Got two of them at the same time. Appreciate you. So we have quadratics. Our x squared are our quadratics. You might hear the word parabola, but their official first name is quadratic. So if we have y equals x squared, we've got that up like a cup version. Remember, positive graphs go up at the end. Negative graphs go down at the end. So we have our negative x squared, looks like this. Negative x squared, like that. All right, so these are the ones that we've seen before. We are like probably pretty comfortable with the first two. The third one, we're like, okay, I remember quadratics, I at least know that they exist, right? And today we're gonna learn three other shapes, and they follow the same sort of pattern. So I have x, so I started with x, I have x squared. What do I call this? X to the third power, what's its like fancy name? Like this is x to the second power, but it's also x squared. This is x cubed. Yes, cubed. Good job, Brandon and Nayeli. Right. So we have x cubed here. This is a cubic function. A cubic function. Yeah, perfect. So we have cubic function. This is x to the third. Positive x to the third looks like this. It goes up. It's kind of like flat, or it can go down, but the basic one goes like this. So that's x cubed. Today, we're also going to see some x cubed that looks like this. 1, 2, 3. The same general shape, right? Same general shape. But something I really love about polynomials is that they give away what kind of polynomial they are by how many times they go up and down. So you can see here, this one goes up once, down, and then up again. There's like three kind of sections of this graph, right? Three kind of sections of this graph, and up and down and then up again. There's three, so it's x to the third. So then when I'm making my negative version, I need it to be going down at the end. So I'm going to go down 1, 2, 3. My negative x to the third looks something like that. That is my cubic function. This might sound kind of funny, but if you are at least in a place where you can talk a little bit, I want you to go ahead and try to say the word cubic. Cubic. Just say it out loud. Cubic. Nice. If we were in class, there'd be a whole bunch of people being like, cubic, cubic, cubic. You can imagine it. Okay. All right. So then the next one, we have cubics, x to the fourth, x to the fourth. Does anybody have any idea what the prefix might be? Notice they all end in IC, ick, the ick version. What could the beginning of this be? Prefix that means 4. Prefix that means 4. How many, let me ask you this. There's one coin and 4 of them make $1. There's one coin and 4 of them make $1. What coin is it?
Quarter.
A quarter, right? And then if you think about like there is like 4 of these make a gallon of water. Does anyone know? 4 of this size make it a gallon. It's a tricky one, but it starts with the same thing that quarter starts with. It's a quart, right? A quart, 4 quarts makes a gallon. Yeah, good job, Mara. 4 quarts makes a gallon. So quarter, $4 makes, or sorry, 4 quarters makes $1. This is a quartic. Turn to your baby sister and say quartic. So you got a baby sister. Turn to your headphones and say quartic. Kind of a weird word to say, quartic. And it has 4 parts. Positive one going up at the end, right? I need this to be going up at the end. So it goes 1, 2, 3, 4. It looks like a W. X to the 4th. Spoiler alert that it can look like a quadratic. It can look like a quadratic. It can look like a flattened quadratic, something like this instead. It can look like this, like it flattens out and then goes up like this kind of. So it can look like that. That's kind of the boring version of it. So I don't draw it that way. I like drawing it to look like a W, but it can technically look like that. It can also have like one of these drops is longer than the other. It can look like that. It can look like this, something like that, right? But the big idea is that there's basically like 1, 2, 3, 4 pieces. All right. What do you think the negative x to the 4th version looks like? What do you think that negative looks like? Yeah, like an M. Nice. Nice. It looks like an M. Yeah, it has to go down at the end. So it's going 1, 2, 3, 4. Something like that. It's going to look like an M. All right. Just this last one, x to the 5th, x to the 5th. Does anybody know when you have 5 of something, if there are, so there's twins for 2, and then there's triplets, and then there's quadruplets. Does anyone know what 5 babies born at the same time is called? Not pen. Quintuplets. Yes, Jasmine, coming through. Quintuplets. This is called a quintic. A quintic. Quintic, absolutely. Okay, quintic has 5 sections, and on the positive one has to go up at the end, right? So this is like 1, 2, 3, 4, 5. It's not really like pointy. Try not to make yours pointy. Try to round it out, but it has like 5 sections. This is x to the 5th. And negative x to the 5th, as all of these have, is going to end down. So it has to start at the top. 1, 2, 3, 4, 5. Something like that. So we have cubic, quartic, and quintic. Try saying that 3 times fast. Cubic, quartic, quintic. Cubic, quartic, quintic. Cubic, quartic, quintic. Whew, that's hard. Okay, so these are our 3 new ones. These are our 3 nouns. After that, after like 5, there are technically other names for them, but most like mathematicians don't use them. They just say to the blank degree, right? So we could technically call this like x. These are like x to the 3rd degree, x to the 4th degree, x to the 5th degree, right? This is x to the 6th degree. So this would be like a polynomial, a 6th degree polynomial. If it was like x to the 10th, it would be a 10th degree polynomial. If it was like x to the 100th, it would be a 100th degree polynomial. So after that, we kind of stopped giving them fancy names and we give them just like this blanket name so we can talk about them. You could call this 5th degree polynomial. That wouldn't be wrong. It's just not the fancy word that we use to describe it. So you'll hear these words more often. That's why I want you to know what they are. Cubic, quartic, quintic. So the polynomial's first name is based on its biggest exponent, on its degree, right? So whatever the biggest exponent is, that's its first name. Whew, these are kind of funky first names, huh? Kind of funky first names. But they have a first name based on their shape, based on their shape. Their last names are based on how many terms they have. What I mean by terms is how many things are being added and subtracted together, right? So for example, on this first one, right, 2x, there's just one term. That term is just 1. There are 2 terms here. Let me zoom in here. There are 2 terms here, x to the 3rd minus 7. There are 2 terms. This has 3 terms, 1, 2, 3, and this has 4 terms, 1, 2, 3, 4. Right? You can have infinite number of terms. You could add more and more terms if you want, but they get more complicated after that. So if I am if I get mono, I have to be all by myself, right? All by myself. If you just have one term, this is called a monomial. Monomial. I know these fun words, they're super fun today. Monomial. Turn to your baby sister and say, monomial. Sounds like a baby word, huh? Monomial. All of these end in nomial. All of these end in nomial. We just have to figure out what the prefixes are. All of them end in nomial. Remember, nomial means terms. It literally means terms, right? So mon or mo, monomial means one term. What's the prefix? There's 2 letters. What's the prefix that means 2? If I am writing, yes, unique. If I'm writing a bicycle, it has 2 wheels, bi means 2. If I like 2 sexes, I'm bisexual, right? That means I like 2 sexes, right? What are some other, if I am biannual, right? Annual means year, that's twice a year, 2 years, like twice every year. So 2, the prefix is bi. So we have binomial. So if there's 2 of them, binomial. What about 3? If I'm riding a bike, but it has 3. Hey, you guys knew already that I was going to say that. It's tri, yeah, like a tricycle. Trinomial. So if it has 3 parts, 1, 2, 3, it's called a trinomial. And then 4 or more. So if it has 4 pieces or more, Moses, that's such a good idea. Quad is a perfect name for 4. However, it's not, it has to mean 4 or more. So it's actually that one that means many. Remember from the beginning what part means many? Many. It's actually the name of this whole unit. Yeah, poly. Good job, Brandon. Polynomial. So if it has 4 or more pieces, if it has 5 pieces or 6 pieces or 7 pieces, right, then it is a polynomial. So we have monomial, binomial, trinomial, and polynomial. Awesome. Okay, let's try naming some. Let's give them first names and last names. First names and last names. All right, here's my first example. You don't need to write any of this down. I just want you to hang out with me. Hang out, answer my questions. Get ready to chat. All right, so for this first one, I first look for the degree. The first name is based on the degree, right, or the shape. The degree here is 4 because that is the biggest exponent. I have 3, I have 1, and I have no exponent here. So a 4. So this is a quartic. I looked over here. I said, okay, x to the 4th, that's quartic. So that is its first name. And then I said, okay, how many terms does it have? Remember, this is how many terms it has. So I have 1, 2, 3, 4 terms. So that is a polynomial. So this right here, this polynomial is called a quartic polynomial. Let's try this one. What is the degree of 11 minus x? What's the biggest exponent? I'm seeing constant. It's not constant because there is actually an exponent right here. What's the imaginary exponent? Yes, the imaginary exponent is 1. And if the degree is 1, what's the name? Yes, good job in the chat. Good job, linear. So this one's first name is linear. Linear. And then how many terms does it have? How many terms? Yeah, it has two terms, so it's a binomial. So this is a linear binomial. For sure, good job. Linear binomial. Be careful, there's no M-O in that, Amira, so it's spelled like this. Spelled like this. Nice. Okay, what about this one? What's my degree? What's my degree? Yeah, my degree is 2. Biggest exponent is 2, so quadratic. Quadratic. Where does the 2 come from again? Yeah, the 2 is your biggest exponent. So your degree, your biggest exponent. So here you had x squared or x to the 1, or there's no x here, so that one doesn't count, right? Nothing there, or x to the 1. So we say, which one's bigger, right? The bigger one is the 2, right? The bigger one is the 2. Does that make sense to us? All right. So then how many terms does it have? How many parts are there in this? 3. Yes, it is a trinomial. 1, 2, 3. This is a trinomial. All right. Our last one. What is our degree of 19? Degree. Yes, good job. It's a constant. There's no x here, right? There's no x here. It's just a number. So remember, with our degree of 0, that's just a number. It's a constant. So this one, our first name is constant. And then how many terms are there? Its last name, yes, is monomial. It has 1 term, monomial. So this is a constant monomial. Oof, they have weird first names and last names, but it's pretty cool, huh? Pretty cool, first names, last names. All right, here we go. We're gonna do some quick CFUs. Quick. Let's do this. I want multiple choice. Here we go. All right. What graph, so we're looking at this blue one here. What graph is this? Is this an x graph, A, this graph right here? Is this x squared? Is this x to the 3rd? Is this x to the 4th? Is this x to the 5th? What graph is this? Vote. You have 5, 4, 3, 2, 1. Get those votes in, and 0. All right. The correct answer is indeed D. It's x to the 4th. Here's how I know. It goes down 1, up 2, 3, 4. Right? So it has 4 pieces. 1, 2, 3, 4. It's x to the 4th. All right. If this is x to the 4th, which of these is its name? Which of these is its name? Is it A, constant, B, linear, C, quadratic, D, cubic, or E, quartic? What is the correct name for x to the 4th? X to the 4th. This one's tricky. 5, 4, 3, 2, 1. All right, look at these results. Look, lots of people thought maybe it was quadratic. Most people thought it was quartic. The correct answer is indeed quartic. Quad is a fake, like it's a false cognate, right? Quad feels like it should be 4, but it's actually not. It's x squared. Remember, quadratic means x squared. So if you have x to the 4th, it's quartic, 4 quarters in $1. All right, let's look here. Let's look at this green one. This green one. This graph right here, is it x squared, x to the 3rd, x to the 4th, x to the 5th? Which graph is it? How many pieces does it have? How many pieces does it have? You've got 5, 4, 3, 2, get your vote in. 1, get your vote in. 0. Yes, the correct answer is C. C. You're going up 1, 2, 3. That's how I know that it is a cubic, or you can look at your notes today. All right, let's do one more. One more. Look at this purple graph. Is this purple graph x, x squared, x to the third, x to the fourth, x to the fifth? Which one is it? Which one is it? Thanks, Brandon. You've got 5, 4, 3, 2, 1. Absolutely, Wendy. That was a good observation. Oh yeah, we know this one for sure. This one is x squared. We've got up 1, down 2, quadratic. We've seen those before. We've seen those before, for sure. All right, last two here. Last two here. Let's do this. I'm relaunching. All right, this is our thingamabob, our polynomial. Is it a monomial, binomial, trinomial, or polynomial? How many pieces does this have? This is our expression. You've got 5, 4, 3, 2, get your answers in. 1. Absolutely, this is a trinomial. It's a trinomial for sure. All right, here is our last quick check question. This expression is this a quintic, a quartic, a cubic, a quadratic, or a linear expression? We know it's a trinomial. What's its first name? What's its first name? Is this what is its biggest exponent? 5, 4, 3, 2, and 1. Oof, look at these. Look at what we got. Looks like A barely won, right? A is the correct answer. Quintic. The reason that our answer is quintic is because the biggest exponent is a 5. The biggest exponent is a 5. So quintic is our answer. It doesn't matter which one comes first. It matters which one is the biggest. All right, y'all did an amazing job. There are 2 pieces of your assignment today. The first one is naming them, right? Naming them. And the second one is IXL. I know you're like, but Miss, you told us we weren't gonna you told us we weren't necessarily gonna have to do IXL. For this one, I do want you to do IXL. Your numbers are very, very small, right? 60, 64, I think star is like 50, right? A low number. And the reason why is because I want you to actually practice with the shape. I did make this note. If you work for more than 20 minutes, I want you to screenshot and turn it in no matter what your score is, right? So if you work for more than 20 minutes on this IXL, you are done, right? 20 minutes, that's the maximum I want you to work on the IXL, okay? After that, you are done. Some people ask for some extra practice, so there is additional practice down there if you want to check that out. Other than that, we are done for today. I'm going to go ahead and open up a breakout room. I'm going to send everybody into the same breakout room, and then you can hang out with Miss Yama. You can ask questions. You can get all of those things in there, get all of your questions answered there. I'm going to go ahead and send you in there now. Have a great day, everybody. Have a great day. Adios, friends. Have a great day. Oh, Miss Yama, what's up? Oh. Bye, friends. Emiliano, Adrian, Roxana, Noemi, Alan, and Nebu, and Jessica. Y'all can pop into that breakout room, get some support. Bye, Roxana. Hi, hello, breakout. Breakout, hi, hi, hi. Oh, I should stop recording the other class. Whoops.